Hello, everyone. Welcome to the OSINT Enhanced Discovery and Profiling Talk. My name is David Deanna. I'm a senior consultant at Optiv Security. I've been doing this for well over 5 years with a background in host security and OSINT. I like video games of all kinds of Star Wars memorabilia and Magic the Gathering card game. Also, Lars Kohenor helped me write this talk. He's also a peer at Optiv Security. He's been working for over 6 years with a background in AD, PostX, and exploit development. Lars is a fellow gamer, likes to play with guitars and walking on the beach by himself. This talk covers OSINT for pen testers. If you've ever been to an OSINT talk or a training course, you'd find that there's lots of material that's covered, well more than you would use for your specific job. So this stuff is supposed to cover specifically the TTPs that pen testers would use rather than forensic investigators or people that are trying to tail individuals. So you're focusing more on the organization. OSINT is used in pretty much every test that you perform, whether you're trying to hack into a building, you're trying to build just a public profile of an organization, or you're doing some sort of like network style pen test. Obviously, social engineering applies here as well. A couple examples of when you would use OSINT is if you're trying to validate the scope of work that a client provided you to make sure that they didn't give you the wrong IPs. Or if you're running a more evasive style test where you don't have any information except for the client's domain name, and you have to try and get as much information as you can about that target. Now, basically, OSINT is considered to be the foundation of pretty much every pen test that you do. Just like I mentioned in the last slide. It's not as sexy as dropping O-days or getting RCEs to pop on perimeter hosts, but it is going to be something that you use on every single test. If you've ever taken an OffSec course, you hear the statement over and over and over that enumeration is key. And once you think you've done enough enumeration, it's time to do some more because you may have missed something in the process. One of the disclaimers I want to throw out there is that if there are tools that you enjoy using and they work well for you, continue using them. This is just going to be a talk that has a couple recommendations for tool sets and TTPs that I've used that have worked pretty well, and it might help you actually improve your OSINT game as well. There are 4 domains that I want to cover related to pen testers, or pen testing rather, with OSINT: IP discovery, subdomain enumeration, metadata analysis, and user and web enum. So there's 2 types of OSINT that I'm interested in here. First one is passive. This is where you're not really touching anything that the client owns. You're using public sources to access DNS records and perform lookups so that basically are touching public-based repos and not anything that the client specifically owns. Again, this is just to keep yourself under the radar, not breaking any rules or anything like that. Now, if you have the client's permission, obviously through your statement of work or whatever you've signed with them, you can start doing active enumeration, active OSINT, where you're actually directly hitting their DNS servers, trying to perform zone transfers, doing port scans, that kind of stuff, trying to get information about their network directly. Now, when you're doing OSINT, one of the things you have to keep in mind is basically OPSEC. If you're using a home IP, that's okay. Just be aware that either at some point your ISP might get mad at you, or you might get blocked by your endpoint if you do a lot of testing with them. And since not all OSINT is passive and you have to touch the client's host at some point, you should always do so behind a VPN. This basically kind of abstracts you from the process, your system, or your home network, and basically makes it harder for the client to figure out who is actually going after them. I can't really recommend a specific VPN client, but there are a couple on the page here if you want to look at those. Just kind of test them out, see which one works best for you. The one thing I will make mention of is the geolocation of the endpoint that you select. In other words, the endpoint that your IP is going to represent should be close geographically to where your target is, so that way it doesn't look as suspicious or, you know, becomes an IOC for their security teams to target. Also, you want to kind of keep track of the IPs that you use with the VPN in case somebody needs to validate that you actually were the, you know, person that performed XYZ actions. Okay, IP discovery. Some of the things you're going to start off with, making assumptions are, is that the client gave you the right scope. They know how networks work. They didn't give you any internally routable addresses, and they know where all their stuff is. Now, that's not the real world. The real world is clients sometimes give you the wrong scope, or they give you extra IPs that they don't own. A lot of businesses will lease IPs from third-party hosting providers, and you sometimes have to validate that those providers are in the know when it comes to testing. There's some still to this day that will actually ask that you fill out all the paperwork, or the client will. In this case, again, it's all about CYA. If you run into any IPs that you can't identify via like host name enumeration, and there's no services or anything tied to that asset that would let you figure out what it is, you need to kind of be careful with this, especially if you have a large scope. If there's like 1 out of 100 systems, chances are it's likely okay, especially if it's part of the same net block. If it's half of your scope, then you're going to want to go back to your client and say, hey, I can't really identify, you know, any host information about these. Can you help me out? And that way you make sure you're not testing the wrong targets. There's some sample tools right there that kind of get you started: host, Whois, and DNS Lookup. I'm going to pick on my company today. I'm going to provide some techniques that will work against them. You're not going to be able to hack them, so don't try. But just some stuff that you can test out with your own targets as you perform pen tests in the future. The scope here is they provided an IP list for a perimeter test, but they didn't give us any host names. So to get started, you're going to want to use Whois through ARIN. You can use the command line or their website to basically check for the net block that their IP belongs to. Once you've done lookup and you found their DNS servers, rather, the CIDR block that IP belongs to, who owns it, what the AS record is, ASN number is for that specific IP, and then registration information about the target. If you only know the host name, the domain name, and you don't know the IP, or you can't resolve a DNS server, chances are you could use ICANN's website to pull that information up, or you just don't like using command line interfaces. This is another way to do the same thing. This is a cool little tidbit that I pulled up when I was doing some research. This is the Whois Registry Data Access Protocol, or RDAP. Basically, this is Whois for the entire internet. So instead of just searching through ARIN and pulling US-based resources, you can actually pull stuff from the entire world. The differences are a little bit more granular than that, as far as like the different types of responses that you can get from the different types of output. And then the command line tool is different for RDAP, but you can use their website as well if you want to try to look up like IPs in different parts of the country. Whois has some command line tricks that can basically pull additional information outside of just your generic registry information that you get from Whois. This is an example on my screen here of looking up the email records for all the POCs for opta.com. The POC record is actually something that's included with the registration information. It's just not something that comes up with a standard Whois search. You have to go a little bit deeper. So you can kind of play with the command line tools and the advanced searches to get information out of Whois. That's a little bit more interesting. Also, the email addresses are likely stale for some of these users. So don't bet the farm that they're actually still working there. However, that could give you a really good indication of what their email schema looks like. After you get that information together, you can use Nmap. Now, I kind of cheated here because I have a list of IPs that I pulled from subdomains of Optiv. But this is going to be basically your IP scope that you were provided by your client. You're going to pretty much do a DNS lookup or like a list scan of all those systems. See if you can try to identify additional host names and kind of create that map of targets for your client. Okay, next we move on to subdomain enumeration. This is kind of the big beast of the talk. One thing I'll say about subdomain enumeration is your data sources are pretty much everything. It doesn't matter what tool you use. If you use a tool that pulls from different sources, the more sources, the better, because the chances are you're gonna get additional records that may not have been stored in every single site, pretty much. There's a tool called, or I'm sorry, a website called Crt.sh. As web security is rooted in the use of certificate authorities, and the certificates that they use allow web servers to prove their identity to browsers by presenting a certificate that's signed by a valid CA. Many of those CAs publish their certs and they put them in a public repo database known as transparency logs. Crt.sh is an aggregate of publicly accessible certificate transparency logs. That was the long fancy description for, you can pull up certificate logs on this website. Censys is another good source. The Censys team uses several tools from the Nmap project to do scans of pretty much every internet facing device. And they scan for common TCP ports, like port 80, 8080, 8000, for HTTP. Then they look for HTTPS, mail services, SSH, DNS, that kind of stuff, to provide a map of different systems on the internet. You can leverage their API with command line tools to pull up the records that way and map subdomains as well. DNSX is a cool tool. You can use it to basically pull up records for, send different queries to DNS servers looking for different types of records. So like A records, quad A records, pointer records, that kind of stuff, to try and find additional information about the targets that you're working with. One of the cool things that you can do with DNSX is you can filter dead records from a list of passive subdomains that you may have obtained from another source, and pretty much just kind of eliminates those false positives that would get in your way. This is just another couple examples of running tools and piping them into DNSX. In this case, it would be like CNAME records, where you're mapping one domain name to another, which is useful when you're running multiple services under one IP address. An example of CNAME would be like www.optiv.com that points to just optiv.com. And it's used to extract subdomains from a given network range using the pointer record. Subfinder is a good tool that's used for discovering passive subdomains of websites. The sources that they use are Censys, Chaos, Recon.dev, Shodan, Spice, VirusTotal, a couple other different sources, even though I think VirusTotal doesn't work anymore for this particular tool. But anyway, pulls up subdomains in sort of the same fashion as a couple other services we're going to be looking at here in a minute, or tools rather. Wordlists, again, sources are everything. Well, if you need to do basically brute forcing of subdomains, and you need a really good word list, this tool will do that for you. In this case, I got like almost 300,000 mutated variants of common names that were applied to subdomains for Optiv. And you're like, why would that even work? Well, sometimes that companies have subdomains that are named really, really, really specifically, and this tool can be used to locate those. An alternative to this would be like running a program like Cool or something like that, the CEWL, against the company's website to pull unique names and potentially find subdomains that way. Now, ctfr.py is basically a Python script that uses the crt.sh site, and it parses the information to pull out the subdomains from that source. So this is a really good command line tool for pulling information from that one specific source. DNS Zone Transfers. basically, as part of the initial list of active OSINT techniques that I mentioned before, basically you can use tools like Amass to do the zone transfers and pull like internal asset names from a company's DNS records. It's not always effective, especially if they have zone transfers disabled, but it's still something that you could use. Sublister enumerates subdomains primarily using search engines and other sources, again, like VirusTotal, DNS Dumpster, Threat Crowd. There's a list there on the page. Basically, you'll have to tweak the script a little bit. When I was using it last, I couldn't actually do a check against VirusTotal because they were being blocked, and there was some craziness with the DNS resolver function. I think it was related to Python 3. So you're going to want to kind of play with that a little bit if you're going to use this tool. But again, it's a really good source for subdomains. Discover.sh is another tool that's more of like a framework than it is a specific tool. It can do passive and active recon, uses a bunch of the methods that I have on the page there. And it can do additional stuff like people searches, but again, that's outside the scope of the talk. It also runs Amass. We're going to talk about that in just a minute. But again, you can do like full reports using this tool instead of just like command line output. ViewDNS.info is really good for performing reverse Whois lookups. That's where you take the domain and you pretty much like run it past some filters. And what it'll do is it'll take the registration information, like the owner or email address of the POC for that domain, and it will actually go in and look for similarly named domains that are owned by the client, or I'm sorry, by that point of contact, and then you'll get a list similar to what you have on the screen. If the client's using domain privacy protection, it's not going to work as well. This viewdns.info website has a ton of different options available for you to play with. When you, if you visit it, you basically just try different methods to see if you can get past that. Because Optiv actually had domain privacy enabled, so I had to kind of play with this to get this list here. Another cool tool is Shodan.io. Shodan really doesn't need any introduction. You can use IPs or domain names to pull specific information about internet-facing devices. If the host name is, the domain name belongs within that host name, or if that IP has SSL certificates exposed, you can find out all kinds of information about who may have owned that device, and also where it's located in the world. Now we're going to move into OWASP's Amass tool, or Amass, however you want to say it. Really cool, like meta tool when you're dealing with Intel for OSINT. There's a couple different modules. The only two that we're going to talk about today are Intel and Enum. Intel is more of the passive module. Enum can do passive stuff, but it's mainly used for active enumeration. Here's a couple examples of using the Intel module where you're pulling information about the domain, the ASN records, the net blocks that are tied to those, and then the right on the page there is basically if you're supplying individual IPs, you can get some reverse DNS information based off like subdomain information based off of the IPs in the list there. Here's an example of using the Enum module. This is using a couple different sources. On the left, just pull the domain name, and the right pulls the domain and the IP. And if you're wondering what the difference is, primarily, it's look at your sources, like on the left, Search Spotter, Hacker Target, Sonar Search, that's hitting a couple different repos. And again, it can actually hit the DNS servers that belong to Optiv as well. Now, if you don't get any results from Amass, you have a really small company, they don't have a very big network presence, or they just are wordsmiths at creating host names. You can use a word list, like with the Altdns tool or similar, and throw it into Amass to do a brute force attack against the DNS servers and see if you can try to find additional subdomains that way. In this case, I found 42 subdomains for Optiv. Those are listed. The subdomains are listed in each one of the ASNs that they belong to, which we'll talk about in a second. So ASNs, what's the magic there? Basically, if you think about CIDR blocks being kind of like the playground for different IP networks, right, or ranges of IPs, ASNs are like groupings of CIDRs, and they're grouped geographically. So if you own an IP address that belongs in a specific ASN, then you'll actually have a bunch of neighbors with a bunch of random host names that they're tied to those based off of the way that they've been leased out. As far as why this matters, you can look up alternate domain names. Names of subsidiaries can be used for subdomain enumeration, and then also you can use Wikipedia to find out more information about that company and who they may have owned, which would then get you those subdomains. You can do additional lookups that way. Here's an example of using, again, just the original Whois lookup, right, with ARIN to find the AS number of Optiv. And you can't really see at the top here, but basically I use the curl command to display the ASN number of Optiv. It's basically just the IPs that Optiv owns within this ASN number belongs to Encapsula, right? And so I went ahead and did an Nmap scan against that one specific ASN number, and it got a bunch of net blocks that were tied to that ASN. At that point, you basically can do a lookup using Amass, and as you can see, there's a ton of different network names that don't belong to Optiv. I think there's only one in that entire list that I found, but you could actually potentially find additional subdomains from subsidiaries or whatnot, depending on how those are set up geographically, and that can help you extend your word list to perform additional subdomain enumeration. So again, it might seem like a long shot, but this actually is valuable on finding additional subdomains, especially of systems that the company may not know that they own that are still spinning. This is a cool ASN lookup tool. I'll have the link at the end of the talk for this one. Basically, it tells you stuff like about the individual IP when you do an ASN lookup on that IP, who it belongs to, right? What network block it belongs to, who the point of contact is. Let's see here, reputation status. If it's a like a Tor node or a known like bad actor, and then the type of IP it is. So like, is it a proxy host, a mobile device, that kind of thing. So that's like for a cool trick for individual lookups using ASNs. Okay, metadata analysis. Pretty much the only thing I have to say is Pymeta. If you're not using Pymeta, you're doing it wrong. It's a command line tool. It's really fast. Foca died on the vine a long time ago. I don't know why it's still spinning, but I have yet to use it effectively in years. MetaGoofil is also a preloaded tool on Kali that works pretty well if you want to use that. It typically wears out on me when I try to use it, so Pymeta is kind of my go-to. Pymeta also parses content using EXIF tool under the hood to create a CSV file for all your data. You can also use it off of files that you've downloaded through OSINT, individual searches and whatnot. So you don't actually have to hit the site again to pull that record or another domain or whatever. So it's good for offline and individual recon as well. Here's an example output. Basically shows some potential usernames and also the tech stack used for some of those PDFs. Obviously Adobe for pretty much everything PDF related, but if you're looking at other types of office tools, it'll tell you whether or not you're using OpenOffice or whatever. Goka is a Golang based version of Foca. So if you are a Foca diehard, this is another way to pull the data that seems to be a little bit better. And again, you can just view it in the command line. You don't have to actually have it in a report. I just started playing with it a little bit, but just to kind of give another option for Pymeta. But again, I'm going to go with Pymeta. Google Dorking, really high level. Here's some keywords. If you want to research it, please just research Google Dorking. But this is a good way to pull up information about file types, specific data from client websites, and just to kind of do a sanity check too. Like if one tool is not working, you're pretty sure they have a bunch of PDF files or whatever. This is a command line tool that does the same thing, only you can actually view the files. So if there's an interesting file you want to look at or download or play with, you can use this method to kind of get a high level view of the same information without using the web. I'm sorry, a browser. Okay, user and web enum. Hunter.io. This is a good site for basically trying to enumerate the target's email schema. Gives you examples like first.last. This is a good way to get started on, user enumeration, or at least this, what you're looking for when you're actually start doing things like password guessing. The really big monster when it comes to OSINT though is LinkedIn. I'm sorry, social media OSINT is LinkedIn. Basically, LinkedIn is going to be your treasure trove of who works at a company and how to get that, how to get their names. Usernames, emails, job titles. These are all targets when you're looking at LinkedIn. It's great for creating a profile of a company. Again, password guessing attacks, social engineering, that kind of stuff. You can't really do anything with a default LinkedIn account. You actually have to seed it. So the first time you try to run it, you're going to get something like this. Basically, you're not going to get any hits, and it's going to suck. An older tool that I used for this was ReconNG. As you can see, I got nothing with a default account. The fix for that, obviously, getting more connections, right? You're going to need to have a bigger network, a more prolific network to be able to find information on your targets. The best way to do this is to create a researcher account, also called a sock puppet account, and you just name a bunch of different names for the same thing. Basically, this is not you, but it is you, right? Here's a couple tips on what you need to do to get started. Make yourself a Gmail account, grab a photo that you can edit so it's not viewable on Google Images. Give yourself a nice convincing summary, light some candles, and get going. There's a feature on the My Network page of LinkedIn where the process works. Basically, there's a people you may know feature. It's their way of tracking your connection requests and sending you suggestions for similar contacts. And you want a quality list of connections for this to work. There's also the concept of called Lions, LinkedIn Open Researchers, or I'm sorry, Open Network, researchers, Open Networkers. That it's like promiscuous mode for LinkedIn. They accept any and all invites. You want to link up with these people. You want to put that on your profile. You're going to want to focus on like IT directors, managers, HR, people that are related to the industry to start generating a quality profile. This is me with over 1,000 connections. And as you can see on the right, I'm getting some people that are actually in the field that aren't just, people from remote areas of the world. And then here's ReconNG with me getting a bunch of connections and seeing their actual information. So one of the things you want to look at in addition to LinkedIn is a site called zoominfo.com. ZoomInfo is kind of like the sales and marketing version of LinkedIn. It's subscription based. You don't have to pay for it. You can you basically view it through Google because they index quite a bit more than what you can view from private sites. They're protected by Cloudflare, and they change their API quite frequently. So if you go out there and find a scraping tool, good luck. It's going to last you a little bit, but then you're going to be back to square one. So again, Google is your friend. Another thing you can use is public breach data to find information on your targets. You can subscribe to a service, but your search history is likely going to be watched, which can create a privacy issue for your customers, so be careful with that. Sensitive information might also, get sold, so be careful with that too. So if you're doing certain types of searches, they might be like, oh yeah, this guy is looking for, company XYZ, and this is the username, blah blah blah. Don't, just be careful. If you're dealing with breach dumps, don't use a browser that can track you. You look up stuff on torrent sites or Reddit. Don't pay for private leaks. You just download them from public sources. You don't go to jail. And if you want to use a pay service, SpyCloud I've heard is a reputable one. But again, just keep in mind that there are risks there. This is an example of me downloading a public breach from BitTorrent, and the output from that file. Again, that was like a 36 gig file. It's massive, so just be careful about that space-wise. Phonebook.cz is another cool site you can use. We just learned about You can dump a bunch of user information. It might be a little bit stale, but it still should be accessible. Next, we're going to talk about web enum. This involves directory brute forcing with tools like GoBuster, GoWitness. It's good for web screenshots as well as Aquatone. Again, you use the tool that you prefer. Wayback Machine is great for looking at history of websites. Sometimes the content on a page may not be accessible to the current version of that page, but previous versions may have that information or additional information available for you to use. Visiting their websites, obviously, 100% the best way to get intel about the company and some of the people that work there. Additionally, DNSX and HTTPX combine create a neat way to get information out of a web server. Web browser plugins like Wappalyzer are great for finding information about the backend server that you're connected to, the web application that's being hosted, and the backend web server that's actually supporting that web application, which is great for finding more information about the tech stack that that company owns. Lightbeam is another great web browser plugin for getting a visualization, a map of the third-party, providers that actually interface with that, tracking cookies that are being sent from different sites. Sometimes you can get more information about other subdomains that are connected to that site. Link Gopher is a great way to just say, hey, I don't want to read all of the links on a page and view all of the content with all the fancy graphics. I just want to view the content via links. So you just run this browser plugin, and it'll spew out all the links in a easy to read page. HTTPX is a great way to take your subdomain list that you got from other tools, pipe it into this application, and then you will get a list of web servers that are browsable that you can actually get to. This is another way to view the same data, only whether or not the servers are viewable, accessible, the headers that go with those web servers, the technology that is living behind that, give you more information about those systems without having to actually browse each one individually. Aquatone, again, is a great web scraping tool. So you take the same subdomain list, pipe it to Aquatone. It will run through the same checks that the other tool, HTTPX, was running through, and it will take a screenshot of all of the landing pages for those sites, which is great for seeing, whether or not they have web portals available to attack. Wireless enumeration is another cool thing. If you are going on site to do a test and you want to see what SSIDs are available, you can type in the address to this cool site, Waggle or wiggle.net, however you want to say it, and view the information about the SSIDs that are being used in that area or have been seen within a certain time window. Also, we'll show you the crypto that they're using, so pretty much WEP, WPA2, that kind of stuff, so you know what you're dealing with ahead of time. So that's kind of a neat little bonus there. Frameworks are a thing. OSINT frameworks like RiskIQ and Security Trails, those actually will give you information about the same data points that we were talking about earlier, only you got to pay for them if you want a subscription, and it's kind of like automating all the things and making it easy mode for you, but you got to pay for it. And we're done. Actually, I'm just kidding. If you guys want to get better at OSINT, and I do recommend that you do this, I would definitely recommend hitting up Twitter. Got a couple handles here, people that you can follow. Definitely hashtag OSINT is something that you want to look into to get yourself plugged in. There are cool blogs and podcasts from different sites like OSINT Curious, for example, that will help you kind of get started if you suck at OSINT. There are also really cool free playgrounds that you can mess with. So Offensive Security has a site called megacorp1.com that you can use to run some tests against. Also, OWASP has their own infrastructure that you can play with to do such things like zone transfers and whatnot. Example.com, net, and org are set aside for this type of testing for additional network-based testing. If you guys want to do anything with OSINT with the dark web, say a client has an issue with their brand and they want you to do additional investigation, this is going to be another completely crazy level of security that you're going to have to take into account. So think of using a Tor browser, several VPNs, a VM that's not connected to your main system to do some testing. And mainly they're looking for information about their brand or if they have any like leaked files or whatnot. Really, really fast primer. Clear web, surface web, that's Google. Deep web is like your bank website, and dark web is everything else. Onion sites are accessible via a browser, like Tor browser, to access Tor node. That's where you're going to find a lot of this data that they're looking for. And then, of course, like companies like American Express or whatever have a login portal that you have to access through authentication. I'm going to pop some links here. You guys can check those out. Just real fast, I'm going to kind of blow through these and can take screenshots as you will. And that's pretty much the end of the talk. If you guys have any questions, please reach out in Discord. Here's my contact information here if you have any questions for me directly. Otherwise, thanks for watching. Have a good day.